asynchronous system for government API. Okay, let me introduce myself up first. My name is Takenaka Kazumasa, and my friend and colleagues usually call me Bamboo or Kazu. I'm from Japan, and my interest in Ruby on Rails, Golang, and React currently. And my company is Manifold. It was established in May 2012. And the stock is listed on market of high growth and emerging stocks market in Japan. And there are 848 members. And when it comes to Manifold Vietnam, it was established in August 2018. And the location is Idempotency Central Building in District 4. And there are 67 members. And we are using Ruby on Rails, Golang, React.js, Vue.js, AWS, and so on. And we are providing many services, and we have 4 sections. B2B section, it's called Money for Business. Actually, this presentation is about B2B section. And also Money for Home, this is B2C section. And Money for X, this is B2B2C section and financial section. And today's topic is about your B2B section. And product name is Cloud Social Insurance, Money for Cloud Social Insurance. Okay. I'm going to introduce the product at first, and architecture overview, and government API overview, and today's topics, and summary. Okay. Let's begin with product introduction. Our product target is back office workers, especially labor section. When a new employee joins the company or retire from the company, or the company pays a bonus or salary review, every time back office workers need to make documents and bring it to several institutions. It's really problematic job actually because the logic of document is very complex and it's updated every year. So we are trying to solve this problem. So user, oh wait a moment, where is here? Oh, cursor is very small. User input data, and then it's actually very basic information. And we save data and calculate values, fill in forms, and so on. And this time, fortunately, Japanese government provides the API to submit data. This API is called eGov. eGov stands for Electronic Government. And eGov transfers the data to several institutions. Then in several institutions, return results. Then we get results from eGov. Then finally, we can show results to users. For architecture, the front end is implemented with React and Rails for backend, and Sidekick for asynchronous job, and we call eGov API from Sidekick. And today's topic is about Sidekick and eGov, this relation. Then let me introduce government API overview. Actually, there are 9 steps in this API. At first, we create submission data. Then we submit data to eGov. Then eGov handles the submission. It's batch processing every 10 to 20 minutes. Then we get the arrival status from eGov. And finally, we can get submission information from eGov. The remaining 4 steps, these steps are not related to this presentation, so today I don't explain. Let's focus on these 5 steps today. We call 3 API on these steps. At first, to submit data, we call PostSend API. Then on step 4, we call Get Arrival Applications API. For step 5, we call Get Reference API. It's like this. At first, Rails create submission data, actually zip file. Then Sidekick calls Send API. Then eGov returns send number. Then for the next step, eGov handles submissions every 10 to 20 minutes. Then after that, eGov transfers the submission data. to several institutions. Then we call arrive applications API by using send number. Send number is written here. We use send number in this step. Then eager returns arrival number. Then we can finally call reference API by using arrival number. Arrival number is written here, so we use arrival number to call this API. Then eager returns submission information and continue to other steps. For each step, we save result on database. Okay. Let's go on to today's topics. There are 2 points in this presentation. The first one is idempotency, and second one is eventual consistency. Start with idempotency. So according to Sidekick Wiki, so idempotency means that your job can safely execute multiple times, and also Sidekick will execute your job at least once, not exactly once. So it matters. Let's focusing on this API, send API step. After calling send API and get send number, for example, when we try to save data to database, it raises and handles the exception. And Sidekick usually automatically retry this step, whole step, but it matters because the submission will be duplicated. So if we call send API twice, the submission data will be sent to eGov twice. So it's a program. Then usually, or generally, there are 2 ways to solve the problem. For the first solution, a client is responsible for idempotency. So it means that check the history beforehand. And for the second solution, a server is responsible for idempotency. So request with idempotent key. So concretely, for the first solution, a client is responsible for idempotency. Before calling post or put API, usually ask the server what I've sent, and then server usually return the send data. So you send this data, then client compare compare the sending data with this response. Then this response doesn't include sending data. Finally, client can call send API. Or for second solution, client usually call send request with idempotent key. Oh, sorry. Then server, oh, sorry. Server usually use this kind of logic, find or create by idempotent key. Oh, what? Then server can execute, make change on same record every time, anytime. Then this time we use the first solution. A client is responsible for it. It means us is responsible for it. Because eGov doesn't support idempotent key. But fortunately, eGov supports sendless API. So this API is kind of history API. When we call it, eGov returns this kind of history list. Then we compare this response with database. Then, if it's already sent, we save missing send number. Then, if not, finally we can call send API, send zip to eGov. Then we get send number and save send number to database. And this is the solution. So, summary of the idempotency. We call send this API beforehand, then ensure idempotency. Let's go on to second point, eventual consistency. As I explained, there are 5 steps in this presentation, and for each steps, many systems are related. It matters. Concretely, on step 1, the front-end called backend API, then raise fetch data from database, then validate data, build. build XML file, and this is Eagle file, and then zip it, then save data to database, also save zip file to S3, then queuing to Sarki. On the second step, step 2, Takeoff process gets data from S3 and also database. Then we call send API. Then eagle returns send number or error. Then we save send number or error to database. Then if it's raises retrievable error, we retry it. Then go on to next step. The next step is 3 and 4. It's like this. So first, static process called arrive application API. But sometimes eagle returns status processing because eagle handles submissions every 10 to 20 minutes. So after eagle handles submissions, we can call arrive application API again. Then it returns arrival number or error. Then we save result and then go to next step. The next step is get submission information from eagle. It's like this. We call get reference API. Then eagle returns result message, several dates like send date and status, and so on. Then we save data to database and continue to other steps. The problem is each step is very complex, and each static process supports, like, so again, according to the static wiki, if the static process supports or crashes the Ruby virtual machine, any jobs that were being processed are lost. So it matters. So our requirement is we must surely finish each step and give the result to users. To achieve this requirement, there are 2 points. So knowing from which step to retry, and knowing if there are the submissions which should be retried. For the first point, we introduced state machine by using Async. So after creating data, the state is before send. Then after sending API, the state will be sent or error before arrival. Then after calling arrive application API, the state is arrived or error before arrival. Then it's easy to know which step the submission is. For the second point, we introduced a monitoring system. It's Ruby script, and then we execute it every night. Then in this script, we check submission data. Then if there are the data, inconsistent data, we retry it. So for the summary of point 2, eventual consistency. So we introduce state machine, and it's easy to know the submission state. And also it's easy to know from which step to retry. Also introduced a monitoring system, and then check if there are submissions which should be retried. For the summary of this presentation, to make it idempotent, we check the submission histories beforehand, and also to make it eventually consistent, we introduced state machine for each step and introduced monitoring system. That's it. Thank you. Any questions?
Actually, just some information from the live stream. So they said that GitLab has some good information on making a sync job idempotency. So there are like links on that. I can share that to you.
Okay.
Is there any questions on the presentation?
Can you solve again the problem? Some of the job not consecutive, and how can you say
Which one? This one?
Yeah, that's right. And how to solve and monitoring system, monitoring cycle.
Monitoring, sidekick monitoring, we are using, wait a moment, I forgot the name. Rollbar for notification, And for this, we just execute the Ruby script every night.
Yeah, in the last year, and I get the same problem.
Yes.
My job, my some of the job is psychic.
Yes.
And when if they didn't finish version about the plots on the psychic database, and yeah, and I really implement some my can I say my solution.
Yes.
And before I send the job to psychist, I store job on the database.
Mm-hmm.
Yeah.
Oh, I see.
Yeah, and I store job on the database. And after the psychist done finish job, and they started job database.
Mm-hmm.
And I done script again. I also check the schedule, or check the job in the database.
I see, I see. Actually, I think it's very similar to our solution. Like, um, so for each step, we save data and fetch data from database. So before sending API, we save data, submission data to the database. Then after that, Sidekick fetch data from database, then sends call every API, several APIs.
And yeah, for now, I get the other issue about the memory on the circuit.
I see.
Yeah, I also I also monitoring the circuit process when it's installed the high memory, and I monitor and I set script restart.
I see.
Restart stack this process. And do you have the same problem?
Actually, fortunately, we haven't had same program for now. The memory usage.
Yeah, yeah.
Mm.
For now, I use my objective view in in the community. They really have the psychic the same when the psychic killer.
Oh, sorry, I'm not so familiar with it.
Uh, psychic worker killer same. Yeah, it's it's monitor and check the memory on the psychic. Yeah. And we, it's when psychic high memory, and
Yes.
it's set in the queue stay on the psychic process, and wait for the current process, the job processing on psychic. When it's done, when it's mean when the psychic process is free, almost the job is done, and the monitoring the Zen can restart. This yeah, this restart circuit. I mean, this free restart circuit and doesn't affect the business logic. So, can you guys?
Oh, okay, thank you. Yes, I'm really interested in it. So after this, please let me know.
Yeah, I just applied this on this month, or maybe this month ago on my project, and I still monitor and check.
Yes.
What is the name of the brand you mentioned? Psychic Killer. Psychic Killer Worker. Psychic Killer Worker. Yeah. It's yeah, before yeah, I have question.
Yes.
During the job development,
Yes.
so there's some reason causing the job in class or the circuit class or Ruby class. So how the error, how you handle the error, the reason the error is set into when the cyclic graph.
Yes.
How we know the reason why why the achieving graph and sending number to the database.
Why? Sorry, you say it again.
Yeah, when the job graph we cannot connect to the database, so we cannot state the error or the sending number to the database.
When you mean this error?
Step 3, yeah.
This error is the kind of invalid submission. Ego returns error, and then we save the error on database, then show the error to users because the submission is invalid.
You mean like how there is no in the cyclic class to send error, right? Yes, we have cyclic class. How we retry the sending number.
How we retry sending number?
Is that in when cyclic class?
Yes.
How can you retry resend the sending number?
Oh, sending number. You mean um, this logic?
Yeah, we say the missing number, right? So when cyclic class we cannot send the missing number to the database.
Yeah.
So at this point, we don't know what the sending number we need to retry.
I see. I see. So we call sendList API, and then we compare the results. Actually, this logic is very complex. So I made another slide, like here. So this comparison logic is very complex.
Okay.
So they send numbers here, and then ego send numbers. This is the response of sendList API. Then we compare the results, data, and then it is a gap. Then there are 4 conditions actually. If this gap is 0, we can submit because no gap there, and so no missing send numbers. Then if the gap is 1 and DB send numbers, so here, this is only one new record. It means that this is missing some number, so we set this number to the database. Then if there are more than one new same numbers, new records, we retry this job because there are 2 jobs concurrently. And for other case, it requires you further investigation, so we manually investigate it. Does it answer your question?
Yeah, it's very complex logic.
Yes, really complex. Any other questions?
Is there any unpredictable case while you are operating this
In this case?
Yeah.
For now, we haven't had this kind of case, fortunately.
Good.
Oh, okay. Yeah, I know some of the repetitive the cyclic process and the cyclic thread in the if you can you say how to configure the cyclic process in the thread on the web the best practice
Actually, we're still wondering. Currently, we have 5 static process, 5 threads. But actually, we don't know with the best solution for now. Just configuring.
Alright, so thank you,
Yes.
Kazumasa
Thank you.
for your presentation. So for now,